All right, now we're ready for the last section of Chapter 8. This is Section 4.8. Now this is doing quite a bit of graphing, analyzing graph, things like that. Just some vocab here. We talked about maximum and minimum for parabolas before. They had one maximum. Technically, that's called an absolute maximum or an absolute min. Well, here you have local max, like in a polynomial. It might turn over a bunch of times. So here, when it turns over, like right here, that's called a local maximum because it's higher than the points around it. Notice the graph goes from increasing to decreasing. That'll be mentioned a lot in calculus. How this goes from increasing to decreasing, so there's a maximum there. Here, this is a local minimum. It's lower than the points around it. Notice it goes from decreasing to increasing. Again, they'll talk about that. Max and mins and increasing and decreasing come up in calculus a lot. Now, there's some more algebra stuff. It's an even function if it's the same on both sides. Like, for example, down at the bottom of your page, you have an even function. This is an even function here. It's symmetric across the y-axis. Notice if you took it and flipped it over the y-axis, it would land right back on top of itself. So that's an even function. Algebraically, to find out if it's even or not, notice it says f of negative x equals f of x. What you do is you take your equation, you plug negative x in for x and simplify it. If it now looks exactly like it did originally, the original function, then it's even. If it's an odd function, if it's symmetric across the origin. These are harder to look at and see. Like this one down here is symmetric across the origin. If you took it and rotated it 180 degrees and it landed on top of itself, it would be odd. Or if you pick a point on one side and go through the origin, there should be a matching point on the other side. So if you pick a point, go through the origin, if there's a matching point, that means it's odd. It's an odd function if you do two things. You plug negative x in for x, and you plug negative y in for y. So you do both of those things. So part of it is exactly what you did for even. Then you also put negative y in place of y. Again, if it matches the original function, then it's odd. Here's just some things we've talked about before. We've talked about zeros. That's where, if you plug that number in, that's where the value of the function equals 0. It's where it crosses the x-axis, so the x-intercepts are 0. It's a factor if you take x minus whatever the 0 is. A solution is very similar to what a 0 is. X-intercept, again, is very similar to a 0. Here they talk about turning points. If it has degree n, it can turn n minus 1 time. So if it has degree 4, it could turn over 3 times is the most. Same thing here. If it has n zeros, it can turn over n minus 1 times. So it has 3 zeros, it can turn over 2 times. Here we talked about even function and odd function. So now, graphing these. So here, if I have this function here, and then you're asked to graph that function. So we have some things right away for us there. One is, we have zeros. So if it says x plus 3, if we set that equal to 0, if you set x plus 3 equals 0, you get x equals negative 3. So that's a 0, so we can put that on our graph. Here, if we set x minus 2 equal to 0, we get x equals 2. We can put that on our graph. We know this function has degree 3 because if we multiplied it out, we'd be squaring this one times x, so this would be x cubed. So this has degree 3. Now that means it's odd and it's positive. Remember, odd and positive is down on the left, up on the right. So that helps us. Also, notice here, x minus 2 is a factor twice. That means this has multiplicity 2. We talked about that before. That means this just touches the x-axis at 2, but doesn't pass through it. It just bounces right back. So if we put some of what we had together, we know it starts down, so it's going to come up through negative 3. It's going to come up and turn over, and then it's going to come back down. It's going to touch 2 and bounce back and finish up. So all we have to do is figure out what happens in between. 2 ways you can do that. One is pick a point in between here. Pick a point usually somewhere in the middle, like pick 0 or pick negative 1, one of those. Like let's say we picked a 0 and plugged it in here. we'd have 1/6 times 0 plus 3 is 3, times 0 minus 2 is a negative 2 squared is 4. So 4 times 3 is 12, times 1/6 is 2. So the point 0, 2 is on our graph. Yeah, I plugged in, like if we plugged in -1, I think you get 3. You want to pick a point in between to kind of know how high or low the graph goes. So this graph is going to look something like that. So we had our zeros, we had our end behavior, and then we find a point in between the zeros because we want to know how high or low to go. Look at this next one. Again, first we have zeros. Here, if x plus 2 equals 0, that gives us x equals -2. X plus 1 means x equals -1. X minus 3 means x equals 3. Again, you just set each one of those equal to 0. So we have a 0 at -2, at -1, and at a +3. So we can put those on our graph. Here again, if we multiply this out, x times x times x is x cubed. So this is odd, and it's positive. So just like the other one, it's down on the left, up on the right. Here, there's not a very big gap here, so we don't need to find a point in there. I would find in between these two, like right in between these two, between a -1 and a +3 is -1. Let's plug -1 into our function. We'd have 1/4 times -1 plus 2 is 1. -1 plus 1 is 0. Oh, I'm sorry. Why did I plug in -1? Sorry, excuse me. That should have been +1 I substituted there. I'm sorry. +1. So 1/4. 1 plus 2 is 3. 1 plus 1 is 2. 1 minus 3 is -2. So that would be 2 times 2 is 4 times 3 is 12. That's a -12 times 1/4 is a -3. So at 1, we're down here at -3. So we know it's down on the left, so we come up through there. There's a short space, so it's going to turn over right away. It has to go through that point and finish up. So there's the graph. Here, finding the real zeros, we've done this really before. This is similar to what we did in 4-6. We want to locate the zeros here. We can do synthetic division. So we go up 6, 5, -17, -6. If you want to try a number in there, well, if you graph that, you'd see maybe -2 is a solution. Remember, we did this we graphed this on our calculator. Go ahead and do that. So if I graph that on my calculator, 6x to the third plus 5x squared minus 17x minus 6. So it looks like maybe it touches at -2. It's hard to tell here and over here between 2 and 3, but it looks like -2 might work. That's why I picked -2. So we have 6. That'd be a -12. 6 times -2 is -12 plus 5 is -7. Times a -2 is 14. Plus a -17 is a -3. Times -2 is 6, 0. So it did work. -2 does work. Now notice we're down to 3 numbers left over, so we put our x's back in. So x cubed divided by x's would be 6x squared plus 5x minus 17. But we need to factor that. Let's see, whoops, sorry, not minus 17. Minus 3 would be a lot better. So we want to factor that. So if we take 6 times -3 is a -18. What are 2 factors of -18 that give us a... Sorry, where did I get 5 at? That should be 7. I'm sorry, I messed that all up. Sorry, I took this line instead of this one. So 6x squared minus 7x minus 3. Set that equal to 0. Again, 6 times -3 is a -18. We want 2 factors of a -18 that give us a -7. Well, that could be a -9 and a +2. So let's do 6x squared minus 9x plus 2x minus 3. If we factor by grouping, here we can take a 3x out of those two. That'll leave us with 2x minus 3. Here we can't take anything out of there, so let's call it 1 times 2x minus 3. So that factors, one of the factors is 2x minus 3. The other factor is the two things we took out, 3x plus 1. Well, now we set each of those equal to 0. So 3x plus 1 equals 0. We subtract 1 and divide by 3. Here, 2x minus 3 equals 0. We add 3. We divide by 2. So our zeros, we had negative 2 that worked. Then from here, we got a negative 1/3. And we got a positive 3/2. Those are our zeros. Or this one again. Let's set up for synthetic division. So 4x cubed, 28x squared, 21x, negative 18. And if I graph that, so we have 4x to the third plus 28x squared plus 21x minus 18. And graph that. Well, it looks like maybe these are kind of in between. 1, 2, 3, 4, 5. Looks like maybe negative 6. So let's try negative 6. So bring down the 4. That'd be a negative 24 plus 28 is 4. That would be a negative 24 plus 21 is a negative 3. And that would be a positive 18 and a negative 18 is 0. So negative 6 did work. So that's one of our zeros. Now again, we put our x's back in. We started with x cubed, so this is going to be 4x squared plus 4x minus 3. We want to set that equal to 0. Again, if you use the grouping method, 4 times negative 3 is a negative 12. We want two factors of a negative 12 that give us a positive 4. Well, how about a positive 6 and a negative 2? So 4x squared plus 6x minus 2x minus 3 equals 0. So these are going to be our two x's in the middle. These first two, we can take a 2x out of there. That'll leave us with 2x plus 3. Here we can take a negative 1 out of these two. That'll leave us with 2x plus 3. So 2x plus 3 is one of our factors. The other factor is what we took out, which was 2x minus 1. So now we set each of those equal to 0. So 2x minus 1 equals 0. So 2x equals 1, x equals 1/2. 2x plus 3 equals 0. Subtract 3, divided by 2. So our zeros were the negative 6 we took out first, and here we had a 1/2 and a negative 3/2. Here, we're trying to find where the max and mins occur at. So here, let's see, we know this one is a cube, so it's odd and positive. So it's down on the left, up on the right. We want to know where it has maxes and mins and it's increasing or decreasing. So let's do that on our calculator. So let's go to y equals and let's put that in there. So y under y equals, we want x to the third minus 2x squared plus x minus 2. And let's graph that. Now it looks like, it might have a maximum right here. These are real good, but it might have a max right here, might have a min over here. Well, we can find those on our calculator. Let's see, this has an x-intercept at, it says find the x-intercept. Well, it looks like it has an x-intercept at 2. So its x-intercept is 2. If you want to check that off your graph, what you can do is hit trace and then hit 2 and enter. Notice it says 0, so that is an x-intercept. Now we can do the max and mins on our calculator. So you go second calc. Notice number 4 says maximum. That's going to ask you left bound. Well, we want to go right of that or left of that point. Well, so it looks like maybe there's a max in here. So I want to go left of that point. So I'm going to go somewhere to the left and hit enter. Now go to the right, and you might watch the numbers on the bottom. Looks like it has a max at 0.333, so that looks like 1/3 negative 1.85. So it has a max, and I'll put it as 0.333, comma, negative 1.852. Do the same thing for a min. We can hit second calc, and number 3 says minimum. Again, this point right in here looks like it might be a low point right to the right there. There's left of that point. Now let's make sure I'm right of that point and hit enter again. Looks like it has a minimum. It says 0.999. I'm guessing that's at 1 and negative 2. So that says a min at 1, negative 2. So if we transfer our graph here, well, we know it crosses the y-axis at negative 2 because this is our y-intercept right there. We said it has an x-intercept at positive 2. It has a min at 1, negative 2. So it's going to, since it starts down, it's going to come up. It's going to turn right there and then right back through here. So it says increasing and decreasing. Well, it's increasing in the beginning. So from negative infinity to where that maximum was, 0.333, it's increasing. So big ideas math, they would say that's when x is less than 0.333 and greater than infinity. It's also increasing over here. Well, it had a minimum at 1, so it's increasing when it goes from 1 to infinity, so from 1 over. So it's decreasing on that little bit in between. Well, that was between the max and the min, so that's between 0.333 and 1. So it's decreasing when x is greater than 0.333 and less than 1. Same thing on this one. First, let's graph that. So x to the 4th minus 5x to the 3rd plus 2x squared plus 8x minus 2. And graph that. Let's see, this one's even and it's positive, so we know both ends are up. If we look at our graph, it looks like maybe let's see, it has x-intercepts. Here it looks like one's at negative 1, but if we check that, I don't think that works. If I hit trace, negative 1, enter, oh, it does work. Oh, see, notice it's negative 2, so that's not an intercept. It's past it a little bit. Well, we can find those on our calculator. So second calc, those are zeros. So second calc 0. So we want to go left of that point. So I'm above the graph, that's to the left, and hit enter. Go right, see I'm below it now. I hit enter again and enter one more time. Looks like it has an x-intercept at negative 1.113. It has another one here, looks like right near 0. So second calc, 0. Let's go over there a little bit. There's one left of the point and hit enter. Now right of the point and hit enter. Enter one more time. Looks like 0.2437. So 0.244. it has a couple more. It has one over here. So second calc 0. So there my cursor is left of the point. Now move it over, it goes right of the point and hit enter. Whoops, messed that up. Second calc 0. I thought I hit the enter button and I didn't. There. So it has a one at 1.821. Then we still have one more. So second calc 0. So go over farther to that next one. There I'm left of the point and hit enter. Now right of the point and hit enter. Hit enter one more time. That looks like it's 4.0477. So 4.048. You could use your less. So those are the zeros. Those are the x-intercepts. Now the maxes and mins. You can see this looks like it has a max and two mins. So again, we can find those. Go second calc. Let's say we find that first minimum. 3. Let's go left of that point. So I need to go way left here. So just follow your cursor to your left of that low point. See here, I'm left of the low point and hit enter. Now go right of the low point and hit enter again and enter one more time. Looks like it has a min at negative 0.574, negative 4.879. So negative 0.574, negative 4.879. And it has a maximum kind of in the middle there, so let's go second calc maximum. So we want to be left of that high point. So see, I'm left of the high point, enter. Right of the high point. So I'm right of it, hit enter, and enter one more time. Looks like it has a max at 1.070 and 4.035. Right? There's our maximum. Now it has a minimum way here to the right, so second calc min. So let's go right of there somewhere and hit enter. Now let's go right. We want to be on the upside and hit enter one more time. Looks like we're 3.2537 and negative 14.949. So it has a min at 3.254, comma, negative 14.949. Sweet. So if we graph that in here, so we crossed here just near negative 1. We crossed again at about a fourth. We crossed again just short of 2, and again just past 4. So it was coming from up, and it turned over somewhere in here, went here, and it turned over again, and went down a ways, and turned over again. So now when it says increasing and decreasing, well, it's decreasing here on the left till that first minimum. So it's decreasing when x is greater than negative infinity and less than that first point, which was negative 1.113. Then it was increasing from that point to the maximum. So it's increasing from that negative 1.113 over to this maximum, which was 0.244. Then it was decreasing after that, so it's decreasing from the 0.244 over to this minimum, which was 4.048. Then it was increasing again here. That's from 4.048 to infinity. Whew. A lot of work. All right, these last ones are just telling whether it's even or odd. We talked about that before. To check and see if it's even, you put negative x for x. So here, if I want to see that this one's even, I always change this to a y, just because I like the way it looks better. So I'm going to put a negative x in here and a negative x in here. So we put in negative x for x. Now we simplify that. Y equals negative x cubed. That'd be plus 12x. Does that match what we started with? No. So it's not even. To check and see if it's odd, you plug in negative x for x and negative y for y. So the right side's going to be just like we already have, because we already did negative x for x. Now we put in negative y for y on this side. Well, here, we would like this to be positive. Let's change the sign of everything. So change every sign. Does that match the original? Yeah. So this one's odd. Same with this, and check and see if it's even. Let's rub negative x for x. So put a negative x wherever there's an x. Now simplify it. Well, at negative x to the fourth, the x just cancels out. So that's x to the fourth. Negative x squared is just x squared minus 7. Does that match what we started with? Yeah. So that one's even. Same with this last one. If we want to see if it's even, negative x for x. Well, if I take a negative to the fifth power, it stays negative. Does that match what we started with? No. So try odd. Again, the right side, we already did it. Let's change the left side. Now we want this to be positive. Let's take everything and divide it by a negative 1. Does that match what we start with? Almost, but not quite. The plus 9 minus sign. So this one's neither. So that's your 3 choices, even, odd, or neither. And that is it for 4.8.